Greetings, fellow explorers. We stand at the precipice of a fascinating journey, a journey into the realm of logistic regression. Now, before your eyes glaze over, let me assure you this isn't some dry, dusty corner of statistics. This is about unlocking the secrets of prediction, of understanding the language of data to anticipate the future. Imagine for a moment the vastness of space. Billions of galaxies, each teeming with stars, planets, possibilities. We as humans are driven by an insatiable curiosity to make sense of this vastness, to find patterns in the chaos. And that's precisely what logistic regression helps us do, albeit on a slightly smaller scale. Instead of galaxies, we have data points. Instead of stars, we have variables. And instead of predicting the birth of a star, we might predict whether a customer will click on an ad or whether a patient is likely to respond to a particular treatment. So, buckle up, fellow travelers. We're about to embark on an exciting adventure into the world of logistic regression, where numbers tell stories and predictions become possibilities. Now, you might be wondering, what exactly is logistic regression? It's a fair question. In the simplest terms, logistic regression is a statistical method that helps us predict the probability of an event happening. Think of it like a cosmic coin flip, but instead of heads or tails, we're predicting outcomes like yes or no, true or false. Will a customer buy a product? Will a student pass an exam? Logistic regression helps us answer these questions with a level of confidence, a probability score. But here's the key difference between a regular coin flip and logistic regression. In a coin flip, the odds are always 50-50. But in the real world, things are rarely so clear-cut. That's where logistic regression shines. It considers various factors, various variables, to determine the likelihood of a specific outcome. These variables could be anything. In predicting customer behavior, it might be their age, income, browsing history. In predicting the success of a medical treatment, it could be the patient's medical history, lifestyle, and genetic predispositions. Essentially, logistic regression helps us make sense of complex relationships between variables and their impact on a binary outcome. It's a powerful tool for understanding the world around us, one prediction at a time. Let's bring this down to earth, shall we? Imagine we're trying to predict whether a student will pass their upcoming astronomy exam. We could use logistic regression to analyze past data, looking at factors like study hours, attendance, and previous quiz scores. We feed this data into our logistic regression model, which then crunches the numbers, looking for patterns and relationships. It might find that students who study for at least 10 hours and have high attendance are more likely to pass. But that's not all. The model goes a step further and assigns a probability score to each student's chance of passing. So instead of simply saying pass or fail, it might say student A has a 90% chance of passing, while student B has a 60% chance. This nuanced approach is what makes logistic regression so valuable. It doesn't just categorize, it quantifies, providing a measure of certainty to our predictions. It's like having a cosmic telescope that lets us peer into the future, albeit with a statistical lens. Now I know what you're thinking. Math? In my space exploration adventure? Fear not, fellow explorers. We won't delve into the mathematical depths of logistic regression, but it's helpful to have a basic understanding of the forces at play. At its core, logistic regression uses a special equation called the logistic function or sigmoid function. This function takes any input and squishes it between 0 and 1, representing the probability of our event happening. Think of it like a cosmic shrinking ray. We feed in our variables, and the sigmoid function compresses the output into a probability score. The higher the score, the more likely the event. There are a few other mathematical terms involved, like coefficients and intercepts, but the main takeaway is this. Logistic regression uses a mathematical model to represent the relationship between our variables and the probability of our outcome. It's like a cosmic recipe, where the ingredients are our variables, the measurements are their values, and the final dish is our predicted probability.